Hi guys, welcome back to chapter 2 part 2. Today I'm going to teach you about variability, the numerical measures of relative standing, the methods for detecting outliers, the graphing bivariate relationships, and how to use mean and standard deviation to describe the data. Let's start with the variability. To measure the variability, we're gonna use range, sample variance, and standard deviation. Let's start with the range. The range is to use the largest number minus the smallest number. The largest number minus the smallest number, and you will get the range within the data. For example, 1, 2, 4, 5, 6. So we will get 1 is the smallest, 6 is the biggest, so we will use 6 minus 1 equal 5. And the range for the data is 5. The next one is sample variance. The sample variance is the measurement of the variability of a dataset. Measurement of the variability of a dataset. To compute the sample variance is to use the given number. The given number, subtract the mean of the data, square, and sum it together, and divide it by n minus 1. The given number, we have to use every number in the dataset. Number in the dataset. For example, we have a dataset like this: 1, 2, 3, 4, and 5. What is the mean of the dataset? The mean is equal to 1 plus 2 plus 3 plus 4 plus 5 divided by 5, which is equal to 3. So we're gonna use every number over here, subtract 3 and square it and sum it together. So it's gonna equal 1 minus 3 square plus 2 minus 3 square plus 3 minus 3 square plus 4 minus 3 square plus 5 minus 3 square, and divided all of it by n minus 1, which is 5 minus 1 equal to 4. So it's gonna equal 4 plus 1 plus 0 plus 1 plus 4 divided by 4 equal to 2.5. So the sample variance of this dataset is 2.5. But the sample variance can write in two ways. For the sample variance, this is the sample variance and the population variance. Population variance is equal to x square or sigma square. This one is called sigma. it is the population variance, and this one is sample variance for the sample. For the sample, for population. The last one is standard deviation. The standard deviation is just the sample variance or population variance, but we square root it like this. Sample variance square root equal to standard deviation, or sigma, which is population variance square root equal to standard deviation. Let's move to the next one, which is how to use the standard deviation and the mean to describe the data. We have to know first that the variability is to measure the distance between the given value and the mean in terms of standard deviation. For example, this graph over here. From here to here is one standard deviation. From here to here is two standard deviation. And from here to here is three standard deviation. So the first rule that we're gonna learn is Chebyshev's rule. Chebyshev's rules tell us that no useful information fall within one standard deviation. So we can write it like this. So no useful information fall between these range. The second rule is 75% or 3/4 of the measurement will fall within two standard deviation. So 75% or 3/4 will fall within this range over here. And the last one is at least 8.9% or approximately 89% or 8/9 of the measurement will fall within three standard deviation, which is over here. Chebyshev's rule will apply to every kind of curve. It can be the Mount curve or any kind of curve. But the empirical rule will apply to only the Mount curve or symmetric curve only. And it says that 68% of the measurement lie within the interval of one standard deviation, and 95% of the measurement lie within two standard deviation, which is over here, and 99.7% of the measurement lie within three standard deviation, which is here. So it's kind of similar to Chebyshev's, but it's applied to a different kind of graph. The next part is numerical measures of the relative standing. The relative standing is a descriptive measure of the relationship of a measurement to the rest of the data. The percentile is mean that X percentage will fall within X percentile. For example, the 25th percentile will have 25 of the observations fall within this percentile. From 0 to 25th, we have 25% of the observation fall between this range. So the next one is quartile. The quartile is just divide the percentile into 4 parts. So the first one is first quartile, also known as the 25th percentile, and we also call it the lower quartile. The lower quartile. The second one is the second quartile, which is the 50th percentile or the middle quartile or the median. And the third one is the 75th percentile, which is third quartile, and the upper quartile. And the last one is the fourth quartile, which is the 100th percentile. So let's move to the next one, which is Z-score. The Z-score is a measure of the distance between the given value and the mean. So as you can see, here, 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 here is all Z-score. It's a distance between mean and the given value in terms of standard deviation. To compute it, we use the given value, subtract by the mean, and divide it by standard deviation. For example, the mean of the test score is 500 and your score is 400, and the standard deviation is 100. So we're gonna use 400 subtract 500 divided by 100, so it's gonna equal -1. So it means that your score is one standard deviation below the mean. Okay, so let's move to the next one, which is methods for detecting outliers. For this one is to detecting outliers, we have to know first what is outlier. An outlier is an unusually large or small relative to other values in the dataset. To detect it, we can use two methods here, which is box plots and Z-score. The box plot is based on the interquartile range, which is equal upper quartile minus lower quartile. It is interquartile range. So to draw it is to be like this. The upper one is upper quartile, the lower one is the lower quartile, and the middle one is the middle quartile or median. As you can see, we can see the inner fence and the inner fence of the lower quartile. The inner fence equal the quartile plus 1.5 interquartile range. For the upper one, is equal to upper quartile plus 1.5 interquartile range equal inner fence. And the lower quartile for the inner fence is equal lower quartile minus 1.5 interquartile range to get inner fence, and the outliers is over here and over here. The outliers will fall within the inner fence and the outer fence. For the outer fence is equal the quartile plus or minus 3 interquartile range. For the outer fence, for the upper quartile is upper quartile plus 3 interquartile range. For the lower one is going to be the lower quartile minus 3 interquartile range to get the outer fence. If the outliers is beyond the outer fence, it's called the highly suspect outliers. Next one is Z-score. Z-score will detect the outliers when the Z-score is greater than 3. That's all. So the last part is the graphing bivariate relationship is to describe the relationship between two quantitative variables. These three graphs, we call it scatter plot. Scatter plot. It shows the relationship between first variable and second variable. If it's descending like this, it's going to be negative relationship. The ascending one is going to be a positive relationship. But if it's no shape like this, it is no relationship at all. Yeah, that's it for the chapter 2, and I will see you for the next chapter.